I've changed the little webcam so you can see my rectangle of paper. Everyone here has 3 pieces of paper in front of them if they follow the directions. We are going to find where all these area formulas come from. And we're starting with, as you see on this screen, rectangles. Rectangles are the easy shape because that's how we define area. When we say that this rectangle has 8 square feet of area, we're really saying that I can take 8 square tiles that are a square foot each and lie them down on the floor of this bathroom or kitchen or whatever and count to 8, right? So we really can't define a formula. It's just length times width because that's what happens when you put pieces of tile on the floor, right? So everyone is good with that. We've done that several days already. But we need the other shapes too. So we're going to start with this friendly triangle in the bottom left corner that has an up and down side. So you're going to take your paper and fold it so that the 2 diagonal corners have a line going between. So it should look like this, right? You're making that triangle that goes up and down. It's sort of like folding a fitted sheet. I'm going to wander around and see if anyone needs help. This basic word on it. There is no origami section on the GED, don't worry. Okay. So don't think too hard about this. How many of your nice triangles does it take to make the whole rectangle? 2. How do you know it is 2? You folded it in half. How do you know it's really a half? They look the same. If I flip it over, I can't tell. Right? So it looks like the area of a triangle is half of the area of the rectangle that it fits in. But maybe that's only because this is such a convenient triangle. Maybe a less friendly triangle wouldn't work like this. So now we're going to go on the bottom right shape. This is another triangle, but now the topmost part isn't on one of the corners. It's kind of somewhere around the middle. Make it look awkward. Don't put it right in the middle either. That will mislead your brain. So here's what we're going to do. See in my little camera, I'm going to take a point on the top edge of my paper and fold it down from that to both corners to make a different triangle. Different triangle, right? I'm taking one point in the corner and going down to both corners. I need something. So one point on the top. Okay, we're doing it right. The spot somewhere on one spot. That's one. Oh, that's one.
Oh, okay. Figured it out.
Okay, so this other triangle you made with some random spot now on the top instead of nicely a top corner. Is this also half of your original rectangle? How would you tell?
It wouldn't be just.
I'm going to give you a hint. So try that. So rip off part of your top corner. Right, we're ripping off one of these two things. And then if we move it to the other side, now we should have one triangle that looks like another triangle. Does that make sense now? Maybe I ripped poorly, or maybe I ripped better than you. Either way, this upside down triangle should look a lot like this right side up triangle, right? Because that one is slithered over there. And that triangle should be an upside down on the back.
Oh, okay.
So it is true for any kind of triangle, not just the pretty ones we did that had straight up and down side first. Any triangle, no matter where the top corner is, it's going to be half of the rectangle that surrounds it. So the rectangle was length times width. So the triangle was 1/2 of length times width. And we would be done, except somebody long ago decided that length times width are taboo words for triangles. I don't know why. And so we use base times height, but it's the same thing. It's just the length times width from the rectangle that goes around the triangle, because the triangle takes up half of it. So if I ask you to say the triangle has a base of 8 meters and a height of 3 meters, find its area. I could just do 1/2 times base times height because I memorized that. But if you like the shape understanding, then you can say, well, there's actually a whole rectangle here. And the rectangle was 8 on the bottom and 3 on the side. So 8 times 3 is 24, but half of that is the triangle, so 12.
Okay.
You don't have to picture the rectangle. You can just memorize the formula and do 1/2 base times height. That's what most people do. But you are smart people. You deserve to know where that 1/2 comes from in the formula. It's because there's this rectangle around every triangle, and the triangle takes up half of the rectangle.
Wow, that was so much easier than I ever thought.
Okay, ready to keep going? Now we have a parallelogram. Parallelograms are like rectangles that elephants sat on. Right? The top and bottom are still horizontal, but the sides are not up and down anymore. So how much of this rectangle does the parallelogram use? So we already did this. Hold up your paper. You had done a little ripping to make the parallelogram. So you have a parallelogram. Don't think too hard. How much of the rectangle is the parallelogram? All of it. It's just the same thing with one little piece moved, right? So if I want to find, oops. So if I want to find the parallelogram, it's the same thing. It's the same area as the rectangle. But this means that I don't care about the diagonals. These diagonals on the rectangles, they're like in the middle of the square. When I move my piece back, I'm putting those two diagonal rips together. And they're like hidden inside the middle. That's not part of what I measure for the area of the square. So when I want to do a parallelogram that has a base, say, of 10 and a height of 2.5, the height is how tall this is top to bottom. Like if these were railroad tracks, how far apart are they? I don't care about this diagonal length at all. That's just a distraction. So 10 times 2.5 is going to be 25 square centimeters. Did I label my other area correctly, by the way? I never actually did do this, right? So 1/2 times 8 times 3 is 12 square meters. If you are fancy and write square meters with an exponent on the M, you're allowed to do that. But I'm just writing SQ because it's easier as we're reading things. So what did I do with the base and the height? I just multiplied them. And because all I am doing is moving this piece back over here. And then we have that rectangle, that's 10 and 2.5, and we multiply them. Everyone okay with parallelograms? Ignore the diagonals, look for how tall they are. Last and most complicated, trapezoids. You have two pieces of paper left. So make a trapezoid. You're going to take two pieces on the top and fold down to the bottom corner. And do this with your pieces stacked on top of each other so that they're covering each other. So I took my paper, I picked two spots at the top, they go down to corners, I have some sort of trapezoid. How do I turn a trapezoid into one of these things we've already done, a rectangle, a triangle, or a parallelogram? And the hint is that you need two copies of the same one. You can't do it with just one. But how do we stick these together and make something that we know what it is? Yes, very tiny top, but. Anyone need help building their trapezoids? So how do we take these and make one shape in parallel? I want to turn a trapezoid into something we already know, so that we get some formula. Can I take these two trapezoids and put them together somehow to make a triangle or a rectangle or a parallelogram? Sort of. If yours makes a triangle, you made an unusually symmetrical trapezoid. They won't all do that.
I mean, just make this six-sided shape that I forgot the name of.
You can put the long sides together and get sort of
Okay.
like a broken six-sided shape. It's not quite as symmetrical as a,
I did it before you said it.
but that's not a shape we know the area of. Ah, okay, I got it. If you take the two trapezoids, let me hold this up to the webcam too,
Oh, I did it.
turn over one of them and put them together, it makes a parallelogram. So revealing things on the screen. There we go. Everyone see what we did? So this is our parallelogram. Ready to write some on the screen? So let me make that bigger. So here is one trapezoid, and we're going to make a photocopy of it. Okay, I'm going to start labeling things. I have a top. I have a bottom. Do I care at all about these diagonals? No. We only care about the height, so I need to make a height. Okay, now I'm done naming things. So how big is this entire trapezoid? Not trapezoid, parallelogram. So how long is this bottom? This part I've labeled bottom. What's this length? That's top. That's the top of the photocopy, right? So the area of this thing is going to be the whole length of the bottom, which we're calling bottom plus top. Times the height. Because we just said that's how you find the area of a parallelogram. You do the bottom times the height. So we did the bottom times the height. Everyone with me so far? That's the area of something that's twice as big as what we want, because we photocopied our original trapezoid. So as a last step, we have to multiply by 1/2 or divide by 2. So this thing here was too big. So what we're left with is bottom plus top times height divided by 2. And that's our trapezoid formula. You don't actually have to memorize this, because I think on anything the GED will give you, you can always draw a diagonal line. Oops, better than I can. Chop the trapezoid up into 2 triangles and use your triangle formula twice. But this isn't that bad, and it is a little faster. So especially if it's on the formula sheet, the GED has a formula sheet they give you, then you should recognize this and know what to do. As an extra little note, you can't always rearrange multiplying and dividing. We've seen that talking about order of operations already. But in this case, I could swap the times height and the divided by 2, and do the divided by 2 first and the times height at the end. And if I did that, it reads bottom plus top divided by 2 times height. And what do you call it when you add up 2 things and divide by how many? Oh, we did this last time. Add up 2 things, divide by how many things there are. We were studying like home prices and things. We added up lots of things. the average. The official word was mean that we learned last time, like the average. So it's the average of top and bottom times height, if that helps you memorize the formula. Okay. And I think that's all for this. Let's do our example problem. So the trapezoid has a bottom that's 8 feet, a top that's 4 feet, and a height of 3 feet. So what is the area? I could draw a diagonal and make 2 triangles and do 2 different triangle problems, and that's kind of annoying, but using the easier formula, then we'll add up the bottom plus the top. Not sure why I'm doing T's instead of pluses. Then we're going to multiply by the height, and at the end divide by 2, because that's undoing the photocopy and we had 2 of these things. So 8 plus 4, 12, 12 times 3.
$30.
36, yeah, 3 tens is 30, 3 twos is 6, and then half of 36. 18, and this time it will be square feet. So there we go, all the different parallelogram formulas you will care about for your GED. And I think that's them. Yep.